Very good evening, children. Now let us learn in the second lesson current electricity, most important topic and then most important concept. Definitely one question based on this concept in your school examination as well in your board examination you will get. So come let us learn tricks and strategies of Kirchhoffs laws. Okay. So what is the purpose of learning this Kirchhoffs law? This is just one of the method for solving complex circuits to find out the current or to find out the effective resistance. So Kirchhoffs laws, there are two laws. Number one, it is current law. Current law. Current law is otherwise called as junction rule. Junction rule. What is this based on? It is based on the law of conservation of. Based on law of conservation of. Law of conservation of charges. So the first law obeys law of conservation of charge, that is nothing but the current law, otherwise called as junction rule. What is the meaning of junction? For example, you have a junction box in a house, sockets are there. So in a junction box, it is a multi-pin where it can be connected to appliance 1, it can be connected to appliance 2, it can be connected to appliance 3. For all the appliances, the current which is coming from the EB box, let us suppose I is the current which is coming from the EB box. The same current alone will be split up into all the 3 appliances. So you can say that I1, I2, I3, if we add all these 3 I1, I2, I3, that has to be definitely equal to, or that must be definitely equal to I. That's called as current law. What is that simple words? Current which is entering into the junction is always equal to current which is leaving away from the junction. So generally how do you write? What is the statement for the current law? So let us see the statement for the current law. Okay. Yeah, it is based on the law of conservation of charges. Now statement, algebraic sum of the current, entering into the junction, into a junction is always equal to sum of current leaving away from the junction. Sum of currents leaving away from the junction. From that junction. So that is equal to sigma I is equal to 0. What is sigma I is equal to 0? So let us suppose O is the junction. So let us suppose O is the junction. Current which is entering in, let us suppose I1 is the current entering in. Can you see? Let us also suppose that I2 is the current entering in. These are the two current which is entering in. What are the current which is leaving out? Let us suppose I3 is the current leaving out and I4 is the current leaving out. Also I5 is the current leaving out. So therefore, you can say current which is entering in, take it as positive. The current which is leaving out, negative. So I1 is positive, I2 is positive, but the remaining all negative, minus I3, minus I4, minus I5 is equal to 0. Or I can say sigma I1 plus I2 is equal to I3 plus I4 plus I5. So this is how we need to make the equation, that is the first law. What is the first law called as, children? That is called as current law. Is also called as junction rule. It is based on the law of conservation of what? Charges. The current which is entering in must be equal to current which is leaving out. Or you can say algebraic sum of the current flowing through a junction is always equal to 0. So can you see here? What is given here? Can you check here? Yes. The algebraic sum of the electrical current at a junction in any electrical network is always equal to 0. Which is the junction? O is the junction. What is the current which is entering in? I1 is entering in. See the arrow mark. I4 is entering in. So I1 and I4 are taken to be positive, whereas remaining all leaving out the junction taken to be negative. So can you check here? I1 minus I2 minus I3 plus I4 minus I4 is equal to 0. Sign convention. What is the sign convention? The incoming currents towards the junction are taken as positive. That means current which is entering into the junction is taken to be positive. The current which is leaving out the junction is taken to be negative. So hope you understand that. Current which is entering into the junction is positive, leaving away from the junction is taken to be negative. In that way only we have done this. Note, the charges cannot accumulate at a junction. The number of charges that arrive at a junction in a given time must leave in the same time in accordance with the conservation of charges. So the charges which is entering into the junction will not be storing at that point. Then and there immediately it leaves away from the junction. Therefore, you can say the charges are conserved. So hope you understand. The next, we will go to the next one, that is Kirchhoff voltage law. What is it given here? Kirchhoff voltage law. What is the difference of the current law? I will show you. Now, Kirchhoff voltage law. So that is nothing but the second law. Second law is Kirchhoff voltage law. The first law is based on current. Second law is based on voltages. For example, battery if you have. From the battery, E voltage has been supplied. Whatever the voltage has been supplied, that alone will be split up across the resistances. So let us suppose the resistance R1, this is R2, R3, R4. Whatever it is, when you consider the effective voltages across R1, that is V1, and across R2, that is V2, across R3, V3, across R4, V4. When you add all the voltages, that will be definitely equivalent to that of the EMF or the battery voltage which has been supplied to it. So simply you can say Kirchhoff voltage law states that algebraic sum of potential differences, or you can say algebraic sum of voltages in a closed circuit. You see here closed circuit, this is all closed circuit. So algebraic sum of voltages in a closed circuit, involving current and involving resistance as well as the battery, involving resistances, that is resistors, and cells instead of battery, cells. The algebraic sum of voltages in a closed circuit involving resistors and cells are always equal to 0. What is the specifically what I is supposed to mention? You have to mention algebraic sum and you have to mention closed circuit. Algebraic sum of voltages in a closed circuit involving resistors and cells are always equal to 0. That is sigma V is equal to 0, or I can write sigma V is equal to sigma IR is equal to 0. Okay, right. Now, sign convention. What is the sign convention? You have to assign sign convention. You have to follow the sign convention. Check here. While you are measuring the potential difference is nothing but the voltage. Okay? While you are measuring the voltage, here it is given the potential EMF is taken negative and travels from positive to negative. But then I am putting it in other way around. Even if you put it in other way around, the answer will be same. Why am I going to write it in other way around? It will be easy. Okay? Right. So now what is the sign convention? Number 1. Sign convention number 1. Sign convention I will write and then 1 I will write here. Potential difference measured measuring potential difference, measured, while transferring, while traveling, you're going to travel in a closed path. So traveling along the direction of current, along the direction of current is taken as positive. You have to take it as positive. See, I am taking it another way around. So taken as positive. Can you check here? Here you are asked to take it as negative, but then I am putting it in other way around. Any method is fine. Okay, this is the method I am following. If it is easy for you to follow, you follow the same thing, or otherwise you can follow the other method. Anyway, answer you will be getting it. But follow strictly any one of the two methods throughout. Do not change it. Opposite to the direction of the current. Opposite to the direction of the current. If you travel opposite to the direction of the current, then you have to take it as negative. Take it as negative. Which one you are taking as negative? Sign convention. Right. While crossing the battery, while traveling, now while crossing the battery, battery, or that means cells, positive to negative. I am going to cross the battery positive to negative. Then you have to take it as positive. While you are crossing the battery, positive to negative, positive. Next, while crossing the battery, opposite way. While crossing the battery, negative to positive. While crossing the battery, negative to positive. Then in this case, you have to write it as, take it as negative. This is the other way around. So, hope you understand the sign convention. Based on the sign convention, previously I have given one circuit. So, based on the sign convention, you have to write equation based on that. So, let me just go to the next. So, the same circuit diagram I am redrawing here, and then I am going to apply the sign convention. You can also do it. It is very easy for you to do it if you know the concept. So, this is E. Let me call it as R1, R2, R3, R4. So, let me call it as A, B, C, D, E, F. I have already told you have to take the closed loop. So, which loop you are going to take? I am going to take it like that. Okay, before taking what are you supposed to do? You have to draw the direction of the current. What is the direction of the current? Always the direction of the current is positive to negative. So, I am drawing the direction of the current here. Is that clear? This current is I. Listen very carefully. This current I splits. Some of the current will go to B to E. So, some of the current is going from B to E. So, that current is called it as I1. What is the remaining current? The remaining current is called as I minus I1. Because I is the current which is coming in. At this point B, it splits I1, I minus I1. That is all, children. Very simple. I minus I1 is coming here, I1 is coming here. Both add up together. How do you know it is to be added? Now only we have learnt. The current which is entering into the junction is taken as what? Positive. The current which is leaving away from the junction, what do you take it as? Negative. The incoming current toward the junction is taken as positive. The outgoing current is negative. So, same thing I am just following. So, now here I minus I1 plus I1, add both. When you add both, what you get? Again you will get same I over here. So, now I am going to consider closed path. Listen carefully, this is very important and very easy, that's all. Closed path, I am going to take A, B, E, F, A. Listen carefully. First I have to go to A to B. So, A to B I am going. Is there any resistance or something present here? Is there any resistance or something present? Nothing is present. Just the wire. So, therefore, nothing is present. So, AB is nil. I have to write it as nil. Okay, what happened to B to E? Next I have to come to B to E. When I am coming to B to E, how are we going? Quick, we are going along the direction. Since it is along the direction, what is the sign convention here? Taken as positive. So therefore, sign convention is taken as positive. So therefore, I am writing it as plus I1 R2. See, this is R2 into I1. Why do I write I1 into R2? Because potential plus I1 into R3. BE over. Next, E to F. E to F, is there anything, children? Nothing. You don't have anything. So E to F, I have to write it as nil. Okay? So E to F is nil. Next, F to E, F to A. How are you going F to A? Can you check here? How are you going? Along the direction of the current you are going, and at the same time you are crossing the battery negative to positive. Check here. So you are crossing the battery negative to positive. So therefore, what you are going to do, in this case, FA, negative to positive, no. So therefore, F to A is nothing but along the direction I into R1 minus E. That is all. Now, as because you are the beginner, you are simply writing step by step. But hereafter, all together as one single equation you write. So therefore, everything together, one single equation I am writing. So that is ABEFA loop. For ABEFA loop, it is going to be I1 R2 plus I1 R3 plus IR1 minus E, R equal to E. You can rewrite it like this, that's it. Next, loop B, C, D, E, B. Now straight away you can write B to C nothing, C to D along the direction, so I minus I1 into R4, and D to E nothing, E to B, check E to B how you are going. So check E to B how you are going. So how are you going E to B? This E to B, you are going opposite to the direction. So therefore, since you are going opposite direction, minus I1 into R3 minus I1 into R2 equal to 0. That is all. So if you want to simplify, you can simplify it, or otherwise you can leave it like that. So these are the two equations. I used Kirchhoff laws and then I wrote the equation. So based on that one problem we will see. Okay. Now find current in each branch. One problem, let us see current in each branch. Horse questions. Find current in each branch of the network. Each branch of network. Simple, I am going to give you one question. So this is the question. Okay, this is the question. It is given 2 voltage 2 ohms, 4 voltage 4 ohms, 3 voltage 3 ohms. It is given, and this is given as A, B, C, D, E, F. I have to apply Kirchhoff laws. Before applying Kirchhoff laws, please see to that any one of the battery you have to take it as and draw the direction of the current. So which battery I can take it? There are 3 batteries available. This one, this one, this one. Any one battery you take. Enough. So I am going to start up with 2 voltage battery. Let me call it as I is a current. When it comes here, what happens? I have to split the current. So when I don't ever see other batteries. Okay. So I am splitting the current. That current you call it as I1. You may be wondering, what is that? Teacher is drawing arrow mark opposite to the battery direction. Because I am not considering the battery. I am taking only one current. So this is I1. I1 is a current which is drawn out from the first battery. What is the remaining current? The remaining current is I minus I1. That is all. This I minus I1 is coming. I1 is coming. Put together, you get it as I only. This is one method. So now I am going to consider the loop A, B, E, F, A. Listen carefully. A to B, is there anything? Nothing. Can you check here? A to B, nothing. B to E, is there anything? Yes, I am going along the direction of the current. But at the same time, I am crossing the battery positive to negative. So therefore, first I am crossing the battery. So plus 4. This is voltage. Okay, so this is 4 voltage. So plus 4 plus 4I1 E to F, is there anything? Nothing. Next, F to A along the direction plus 2I. And how am I crossing the battery? Negative to positive. So minus 2 is equal to 0. Simplify quickly. 4I1 plus 2I plus 4 minus 2 is plus 2, that is equal to minus 2. Equation number 1. Similarly, I am going to take B, C, D, E, B. Take it like that. B to C, nothing. C to D. You take C to D, how you are going? I am crossing the battery. How am I crossing the battery? Check here, positive to negative. When you cross the battery positive to negative, what is the sign convention here? While crossing the battery positive to negative, take it as positive. So therefore, I am taking this positive plus 3. Along the direction I am going, check here. Since I am going along the direction of the current, I have to take it as plus 3 into I minus I1. Okay children, do you have anything E to D? Nothing is there. Okay. Next, E to B. How are you going E to B? You are going opposite to the direction of the current. Since it is opposite direction of the current, I have to take it as minus 4I1. How are you crossing the battery finally? Negative to positive. That is equal to negative. Is equal to 0. Now I wanted to simplify. 3I minus 3I1 minus 4I1 minus 7I1. Check properly, you also do it. Minus 7I1 minus 4 plus 3, that is minus 1. So equal to 1. That is equation number 2. That is all. Now what are you supposed to do? You have to solve both. Let us solve. Next page. 4I1 plus 2I is equal to 4I1 plus 2I is equal to minus 2. Is that clear? Is it 4I1 plus 2I is equal to minus 2? Yes, plus 4 minus 2 is 2, so minus 2. Minus 7I1 plus 3I is equal to 1. Minus 7I1 plus 3I is equal to 1. So what you do, the first equation multiply with 3. Second equation multiply with 2. That is all. So let me do it. 4I1, that is 12I1 plus 6I is equal to minus 6. Minus 14I1 plus 6I is equal to 2. That is all. So minus 6 minus 12 plus 14, 26 I1. This get cancelled is equal to minus 6 minus 2 minus 8. Therefore, I1 is equal to minus 8 by 26. You may be wondering what is this negative you are getting. You can get negative. Negative is nothing but opposite to the direction we are going of flow of current. Minus 8 by 26, that is equal to minus 4 by 13 amps. Okay, I found out I1. Substitute in any one of the equation. So therefore, I can write 4 into I1 plus 2I is equal to minus 2. So 4 into minus 4 by 13 plus 2I is equal to minus 2. So therefore, 16 minus 16 by 13. 2I is equal to minus 2 plus 16 by 13. So I is equal to. So what is 2I is equal to? Minus 26 plus 16. So that is equal to minus 10 by 13. So 2 and 5 times it get cancelled. So what is the final answer, children? I will be equal to minus 5 by 13 amps. That is all. I found out. I1 I find out. Check. I found out. I1 also I found out. That is all. Is that easy? Yes, it is very easy. I will give you one question homework which you can do by yourself. You get it, children? Is that clear? One question I will give you as homework. You can do it by yourself. An assignment, do yourself. Do yourself. Find current in each branch. Current in each branch of the circuit, or find I and I1. That's all. So one question I am giving you. You can do it. 5 volt, 5 ohms. 10 volt, 10 ohms. This is 2 ohms. Take this as A, B, C, D, E, F. So you try solving it and then come and tell me whether you are getting the correct answer. Okay, children, thank you, children.